So here's our agenda for today. We are going to be understanding where data is coming from in the database and how a map uses that data. We're going to highlight some areas on a map that may be useful for contouring. We'll be building some contour maps from different sources of data inside and outside of the database. We'll be also determining the best practices for contouring using data sources and grid parameters. And so a lot of this will be using WellBase, Zone Manager, and Geo Atlas, for those of you familiar with geographics. And then when Lee presents, she'll talk more about this, workflows containing on how to build, what data sources are usable for building maps in Geo Atlas, as well as the best practices for contouring isomap data. So when Lee presents, she will kind of go further into detail on these topics here. So with that, we will jump into the demonstration. And then we're going to start here in WellBase. So in WellBase, this is where all of our data is stored. So think of this as the brain of the operation. This all of our wells are stored, formation data, production data, survey, core, DST, IP, anything that is going to be necessary for us to just have any kind of information about the well. And as you'll see here, everything is integrated. So anything that's here in WellBase, what we have stored here, is usable for building maps, for building cross-sections, log analysis, seismic display, smart section interpretations. Everything's all integrated. So what you see here, we'll be able to use in those other modules. So we're just going to start out here. I'm going to kind of go through this real quick. We are working in a place called the Williston Basin here that's in the north of the United States, in a state called Montana. We have about 700 wells or so in this project. I've filtered it down here to about 350 that are just wells with production, just to kind of show you some of the data that we're going to be looking at in Geo Atlas here momentarily. So in our formations tab, here's all of our formation data stored. You'll see I have my list of all my formations, who's picked them, and their tops. And this is the data that I'll be using to build some of my structure maps. So looking up here, for instance, on this well, I have a Green River pick that I've picked, a Green River pick picked by another geologist, and a Green River pick that has been brought in from vendor data. So you can see I have many different picks and sources to use when building these maps. I'm going to jump over to the production data here. So we'll be looking at that in a moment. Production data is going to be stored by month in this case. Each month has a production value. Here's my volume for oil, gas, and water we'll be looking at, and the producing zone that is producing these values, and some cumulative sum together values there at the top. And one of the important distinctions that I want to make here about data inside geographics is that data is going to be stored as either text or numeric data, as well as date data. So if you ever want to store data in a certain area and you're not quite sure if I'm putting a number here, but it may not be a numeric, that means I can cut this oil column here. I'm going to right click on it, and I'm going to go to unit of measurement. And if I get a unit, then that tells me that this is a numeric field. The unit here is in barrels. That's a numeric field. Zone alias, however, is text data, and I can find that out by doing the same thing. Right-click here and go to unit of measurement, and then it tells me it's not a numeric field. So that's text data and numeric data. That's going to be a very important distinction as we start looking at highlighting data on a map using some features called thematics and bubble symbols, as each type of data is only usable for one or the other. And then date data, kind of the same way, not a numeric field. All right, so with that pointed out here, we're going to jump over to Geo Atlas. And I've got a map here displayed with a couple wells. I filtered this down to just a couple wells, and we'll see why in just a moment here. And these wells are posting currently just a well number, a well name, and this purple value over here is going to be the subsea posting for a come back and see some more about that. We're just going to take a look at this layer here. So I'm going to update the layer. So right now I'm currently posting, like I pointed out, the well name and number and a formation top subsea value for the Red River. Down here in the lower left corner, I have something called the map tip bin. And in the map tip bin, I have stored some information. For instance, I have a couple formation tops listed in here, some header information about operator, spud date, county, some zone information based on some attributes that I've selected, some production data. This is the cumulative values for production for the cum oil, cum gas, and cum water. And then some more header information, TD, completion date, datum elevation, as well as the well status and the well ID. Like I said, I've applied a filter here, focusing on just some specific operators. So I'm going to start looking here in a minute with thematics, bubble symbols, and proportional pies. The data that's going to be available for me to post is going to be dependent on the data that I have stored here in the map tip bin. So if I want to highlight on my map some data that's maybe a specific formation, I'll have to add that information in here, like let's say source or you know, like a net thickness. I'll have to my map tip bin down here, and I can do that by simply clicking and dragging that value into the map tip bin. And once it's stored here, it doesn't have to be posted on the map. Once it's stored down here, I can then use that to build my thematics and my bubble symbols. So now we'll look at a couple thematics here. So in my thematic field, you'll see I'm on my my WellBase layer here, and I've selected the straight hole well entity. You'll see I have a couple that are straight hole wells and a couple that are deviated wells. You can see the deviated wells over here in the Bakken field. Within the straight hole well, I'm going to apply a thematic here, and this is going to highlight on my map some information that is going to be useful for me in determining what wells, in this case, what wells maybe my company is operating on, wells that another company is operating on, or just kind of figure out who's operating on what in the area that I'm working in. And if I click the drop-down box here, you'll see there's a list of all the other fields available to me from the map tip bin that we pointed out earlier. As I noted before with the numeric versus text data, you'll notice I don't have cum that I had added to my map tip bin. And again, that's because that is numeric data. Thematic mapping only works on text data. So I have my completion dates, I have my well names. The well number is technically stored as numeric data, and some information, and I'm going to start with operator first. So looking at my operator field here, I'm just going to sort these here real quick. Looking at my operator fields, I've filtered this down to just 5 specific operators. So there's more than 5, and that's because some of these names are repeating. So I have Loof EXPL Co. and a Loof Kenneth Inc. That's 2 instances of the same operator, and they each have a different color to highlight them. Now, I don't want that. I want to have those both show up at the same color, and instead of going through here, and in this case it's not a very long list, but in most cases you'll have a longer list than this. I don't want to have to go through there and individually pick that same color for each of those instances. So what I'm going to do is use a function in here called the wildcard that allows me to consolidate values into a single value. So I have 2 instances of Loof here, one at 41, one at 26. And then what I'm going to do is I'm going to here and use this asterisk here as my wildcard, and I'm going to update the counts, and it's going to sum those 2 together and include them now in just this one field. And now I can go up here and remove those other 2, and then go through and apply that to the same other operators in here. And see Slauson has a couple, Pennzoil will have a couple, Continental will have a couple, and I can go through there and do the same thing. I've done this previously and saved it, so this is a really neat feature here. I can set this up and then save it so I don't have to set it up each time I change a field up here. So I'm going to grab my operator here, and that's saved. So I'm going to update the count. And they disappear. Cool. Okay, well, I'll just do this here real quick then. Using these operators, these wildcards, I can consolidate this down to a much more usable and recognizable kind of field here, and so I can limit this down to just the ones that I'm interested in. So I'll do this one more for this one. Okay, so that's a lot more manageable. Now I've just limited down to just 5 specific operators instead of having 10 or 11 there. And then I can apply color palette and set the number of colors here. We're at 5. And then I'm going to change the size for these. Make them a little bit easier to see on the map. And then when I apply, it asks me if I wanted to post this at a surface hole location or a bottom hole location. And I'm going to apply this, if this is on deviated wells, and I can apply it to both. I'm going to apply it to the bottom hole location of the deviated wells. And as you can see, I've now highlighted on my map the operator that I highlighted on the operator on the map, so I can kind of figure out what wells are being operated by who. So I can kind of figure out fields that I might want to work in specifically, like I only want to build a map based on a specific operator data. I can now highlight that and figure out where I want to build my maps. So that's using operator data. I'm going to switch over here real quick and take off the filter. So when I finish applying these, you'll see I'll still have the thematic highlighting those specific operators. Now I just have a couple new wells added to the map. So now I want to go back here real quick. I'm just going to show that I can do this, the same fields up here with completion date. So with completion date, you see I have a couple operator or completion dates listed here, ranging from 1950 all the way up to the 2000s. And again, each one getting their own specific color. So like we saw before, I can use wildcards to limit that. And I'll just kind of show this real quick. So I just do 1960s, 1970s, and then 1980s. I'll update the counts and then remove all the other ones there. And so as you can see now, I just have the 1950s, 90s, and 2000s left there. And I can go through and keep adding those wildcards in there to limit that. But just kind of showing you that you can do it both with your text data there and with dates. And I'm applying the wildcards on any month and day here listed for the day for the year, and then any numeric listing in the 1960s, all the way from 1960 to 1969. And as I go through there, again, updating the counts and removing anything else makes this a lot more manageable for me to highlight based on specific values, as opposed to going through here and changing colors on individual months as I go through this long list. So just a lot easier for that data there. So we're going to jump into bubble symbols here now. Now we saw before, I've added production data to my map tip bin, and we're going to be bubbling here on the production data. Within, as like I mentioned before, the data types are very important for this type of data. bubble symbols as the opposite of thematics, where thematics has to be, can only be used on non-numeric data or text data. Bubble symbols has to work with numeric data. So I'll see up here if I go up to change the field. See there's my cum oils, there's my zone manager attribute data, some TDs, datum elevations, and then some top sub C and top MD values based on some of those formations that I've added, but nothing about the formation name itself or any other text data that I had stored in there. So you can see the difference between the two fields here and how we're highlighting data. So with the bubble symbols here, I'm going to look at cum oil volume. And one of the neat features in the bubble symbols, you saw before, we can use the wildcards to help us limit data and the thematics. In the bubble symbols, I'm using data ranges instead. Instead of getting just individual values here and applying a color and a symbol to those, I'm getting a range of values. And so I can control that range here by setting either, manually setting my range or by setting a minimum and a maximum value and then ramping the rest of the values. So for instance, I'm at 0 to 2.5 million here. Let's just make it this 0 to 100,000. And it updates the values here, ramping all the rest of them and giving you the data ranges in between those, all dependent on the number of intervals that I have selected. So I can up those, make them fewer, and again, just ramping the values. So I'm going to go back to that 0 and 2.5 million. And one more. Okay. And I can do the same with colors as well. So I'm going from a light green to a dark green here. I can change this to a light red to a darker red, ramp the color values, and then the size of the symbols. So this way, if I just want to find out which wells in my area are the biggest producers, I can give them a larger symbol. So I'm going to set that. I have set that set up here. Smallest size is going to be 1,000. Biggest size is going to be 5,000 here. And you can change the symbols for these as well. Right now they're just circles. So when I look at this, again asking where I want to post the non-deviated wells, and I think I have too many zeros here. There we go. Now I can kind of see on the map where the biggest producers are. So you see this is cum oil. Here's a big oil producer, some other bigger oil producers. Got some good producers out here and up to the north. And then everything else kind of just has these smaller circles indicating a smaller value, as then a couple wells that don't have any symbols at all because there's no production data present. So I can set all that up here in the bubble symbols. So again, just highlighting on a map where a good place to drill would be, maybe build some production maps on some specific type of data. You can also see the smaller bubble symbols are being drawn on top of the larger bubble symbols. That way they're not getting covered up, so you can still kind of see if there's small producers in these big producing zones. And then as I go through here, I can change the field. Cum oil, I can do one for cum gas, I can do one for cum water, but you can only have one bubble symbol applied per layer. So if I wanted to set one up for each type here, I can create a layer for cum oil, I can create a layer for cum gas, I can create a layer for cum water, and have all of them displayed there with the bubble symbols. Or I can use something else here called proportional pies. That off here real quick. What the proportional pies do is I've set them up here to display cum gas, cum oil, and cum water all at the same time. So a little bit like the bubble symbols, larger producers get a larger chunk of the pie and are displayed larger. I can highlight on the map again just where my big producers are, and I can look at 3 different types of value all at the same time. And I can set this up to as many types of information as I want. It's not just limited to the cum oil, cum gas, cum water. Again, data posted to the map tip bin is going to be available to me. So there's some top depth information, top sub Cs, my zone attribute data, just TDs, observation number information, again, all numeric data. So it's important that you store the numeric data in the correct area and indicate that it's numeric data. Even if you put a number in a non-numeric field, it will not be picked up by the pie charts or the bubble symbols. As I go through here, I'll just kind of point out I'm applying a sort of a multiply by value here for my cum gas so that I make sure I have the correct value here. I'm multiplying by the variable equivalency on those values stored in WellBase. And I've set up over here to give a variable radius for each wedge. Again, larger producers get a larger chunk of the pie and are displayed larger than the smaller ones. So here's a big oil producer, a little bit of gas, a little bit of water in there. And I can kind of just point that out real quick on the map. So just zoom out and kind of take a look at it. So again, there's a big water producer there. There's our big oil producer, some other big oil producers, and up to the north, I got a couple good ones there. So again, just highlighting on the map and figuring out where a good place to drill might be based on some surrounding production data information. Excuse me. So now with this kind of data highlighted here, I'm going to toggle that off here real quick. Again, choosing where you want to display that. Now that I've highlighted that type of data, I'm going to highlight some other types of information. Maybe I want to figure out just kind of real quick, I don't want to go through all the setup of building these layers to highlight this type of data. I just want to figure out what wells in my project have a certain type of data. So there's a couple ways we can do that. One is to right-click on the map here, and I have these highlight wells options. I can just find any well that has production data, any type of production data, raster logs or digital logs. This is my LAS curve data. I can highlight those on a map here. Just kind of click that, and I get a yellow dot showing that. The other way, I think this one's a bit more usable because it has a lot more features applied to it. Is this other symbol up here that's the conditional pi symbols. What this is going to allow me to do is set up multiple fields here to look up information in. So I have the scout field. I can click the drop-down box here, and you'll see I have some basic header scout table information, completion date, data date, and then it's the date that data was brought in or last edited, name, status, anything like that, and just figure out, highlight wells based on a specific field there. And then also some other more useful ones down here is wells with certain types of data, wells that might have a certain zone attribute, wells that have a certain formation top, wells that have raster logs. Let's just apply this one. So I can see here's all my wells that have raster data. If I want to add another one, let's look for wells that have digital logs. It's going to be LAS data. And so what this one does is allow me to look for wells that might have both kinds of data. So you'll see in the pie charts, or I'm sorry, the conditional pies here, if it has a red and green, that means it has both. If it's just red, it's just raster. If it's just green, it's just LAS data. So I can figure out data based on specific values like that. So now I'm going to do one here. Let's look at production data. I'm going to look at wells that have some production. So let's apply that and see a lot of wells that have production data. We saw it before with the bubble symbols. But I can do this here based on a specific producing zone. So the Red River, quite a few there. I can change that to the Bakken. See, over there in the Bakken Zone, I have a couple. You see mostly the deviated wells there. And I can kind of go through there. And instead of going through and adding each time, I can set up one that just says all. And it does that automatically here for me. And then highlights on the map those producing zones. And then again, if well has multiple producing zones, they'll get multiple colors here. So now that's looking at some production data. Clear that up here. I'm going to look for wells that have a specific formation top. Some information for Lee's presentation next here. Go to tops, a list of all the formations that I have available to me in my strat column manager. So let's just see how many wells my project have a Red River top. So you got quite a lot there. So that's going to be a very good information for me to use to build structure maps because I got a lot of good data, a lot of good well control. So let's look at how many wells have the Bakken pick. Again, a lot of good data, a lot of good well control on that pick. Let's look at one that might not have as much as, say, the Newcastle here. Not as good well control, just a couple wells that have some data in there. So I might want to build a more local map for this type of data. Maybe build a boundary polygon around some points over here, some points down here to the south, where the data is more localized controlled. Because if I try to build that map across my entire area here right now, again, I'm not going to get a very good result because I'm missing a lot of points in a lot of areas. So I can just go through here and kind of figure out, highlight my map and figure out what certain types of data I have available to me to build these maps. So it's a very useful tool for getting kind of figuring out what I want to map on first. And as you can see, you can go through there and pick any formations you want, get multiple formations listed in there. As we saw with the producing zones, I do not have an all. I do have an any, just kind of give me all the wells that have picks, as well as wells that don't have any picks. So I can figure out, these might be recompletion wells, or the actual well itself has the formation information on the recompletion one, does not have the formation data, or these are wells that I've manually added to the map and haven't picked any data for yet. So I can kind of figure out where I might need to build a cross section and start picking tops. So all that is controlled here with the conditional pie. So it's very useful for figuring out what type of tops and what type of data that I want to use to build these maps. Create a layer here. And just say wells with no tops. And with that layer, again, I can now toggle that on and off and come back to that layer anytime. The symbols get a little bit smaller here based on the size that I had selected up here. So I can make that bigger. That increases the size. So again, it's very useful in figuring out, just kind of look at it, figuring out the data that I want to use to build this map. You see formation table is blank, so now I can go through and start picking tops for that well. So yeah, now that we've highlighted on our map the type of data that we want to use, again, focusing mainly on the Red River and the Bakken, I can see good well control, so I'm going to use this Red River pick to build some structure maps. So with that, I'm going to hand it over to Lee, and Lee will talk about using this data now to start building some ISO maps and what type of, how you can create those maps. So let me jump over to Lee here and let her take over.
Great. Thank you so much, Andrew. My colleague Andrew just showed examples of how to graphically visualize the available data in a project in Geo Atlas. In one example, he showed a large number of wells with picks in the two major producing zones in the Williston Basin. In the second half of the webinar, we'll cover the basic workflows for contouring and geographics, so both creating and updating ISOMAP layers. Now, ISOMAP is the name for the contouring module within Geo Atlas, so you'll hear that name a lot. We'll cover the best practices for contouring and some basics on refining grid parameters. We'll create ISOMAP layers from various data sources. We'll start with WellBase picks, then we'll consider other sources of data both inside and outside of the database. We'll start by creating contours for the structure of the Red River Formation. This is the older major producing zone in the Sioux Pass field of the Williston Basin. Now, the Williston Basin is quite large. It spans several states in the northern U.S. My map is zoomed on a 5x5 township known as the Sioux Pass field. Not only is my map cropped, but I also have created an area of interest in my Williston project. This area of interest, or abbreviated as AOI, it filters the database, so it limits the wells I see in WellBase, and it also filters layers geographically to only the extent of the Sioux Field Pass area. Any new layers will get created under my area of interest in Project Explorer, so that's how it fits within the project structure. And you can tell that my area of interest, or AOI, is active by the yellow arrow in Project Explorer. So now we'll go ahead and create a local Red River structure. The quickest way to contour map is to right-click the subsea posting that we've added to our WellBase layer, and this is displayed in purple. So I'll zoom in on a few wells that aren't too tightly clustered. I'll go ahead and I'll set my WellBase layer as my active layer up at the top of Geo Atlas, and then I'll select a single WellBase posting. I'll right-click and I'll pick Contour. I get a couple of screens flashing that the software is working, and then I'll zoom back out, and I instantly have a structure map of my Red River contours. Now, that was really quick. You saw a few little dialogues flash what happened behind the scenes. The steps ISOMAP takes during contouring grid mesh across the entire active AOI. So imagine laying a sheet of graph paper over your map. Next, the software collects the control data points for the specified data source. So in this case, that's those Red River tops that were displayed in purple. Then values are calculated for each grid cell in the mesh, or piece, each intersection on that graph paper. ISOMAP uses nearby data points, and it interpolates using the parameters specified in ISOMAP. Now with this quick right-click contour option, we just use the default ISOMAP grid parameters. Once each grid cell has a z-value assigned, ISOMAP laces contours through the grid. Note that the grid mesh is contoured and not the actual control points. And finally, if specified, any color is added. So that was the quickest method for creating contours from a WellBase layer posting. Now we'll create a layer and we'll contour directly from the database. So we'll close those contours and we'll go up to the ISOMAP contour menu. This is sort of the heart of ISOMAP within Geo Atlas. I'll go to ISOMAP Build Surface, and the first screen I get is a Data Sources window. So I'll go ahead and give a layer name. I'm making a Red River structure. And now I'm prompted for data sources. So I'll click the Add button, and you can see the different sources available to ISOMAP. I can use WellBase. I can get inner well pics from cross-section. I can go to the Zone Manager module within Discovery, and I also have a variety of ASCII imports that I can access. Now in this case, I want to go straight to the WellBase database, so I'll pick that and click OK, prompted for more information. So I want to go to the Formations table, which holds my picks. I'll pick my top subsea field, and then I need to select my Red River formation. Okay, I have a number of sources available. In geographics, you can flag each pick with the source of the data so you can decide which sources are more or less reliable. I'll go ahead and pick my own source. Of course, I like my picks. I've done a good job here. My colleague James is also correlating in the Red River, so I'll pick his pick secondarily. If I have a pick, I'll get it first. If not, I'll take James. And then if neither James nor I have looked at a well, I have a variety of vendor sources from IHS that I'll go ahead and pick as my other choices. Now I have a slight preference for the IHS driller picks over sample, so I go ahead and move that up in the list so it has a slightly higher preference. I'll go ahead and click OK here. And the software queries the database, and now I can see I have a data source. I'm going straight to the WellBase database from the formations table, and I'm mapping the top subsea of the Red River. I can see my min and max values. I have 377 picks, and this is my average right here. So I'll go ahead and click Finish, taking all the rest of the defaults for gridding, and I can see that I have a structure, and it's almost identical to the one that I had just created. So now we've seen two common ways to contour picks, from a WellBase layer or directly from the database. Next, I'll update my layer to reflect changes to the data. Okay, down in the south, I see a big bullseye pattern in the southeast. This pattern could indicate, well, with a pick that needs refining versus an actual anomaly in the Red River. So I'll zoom in here. And once I'm zoomed in, I see that there is a well with a pick that it's much shallower than the surrounding tops. To weigh this pick, I'll create a quick correlation cross-section with a nearby well. So I'll set my WellBase layer as my active layer, and then I'll go to cross-section, define cross-section, well to well, and I'll just take this well to the west and over to the suspect well. Now I've been correlating, so I already have a template set up for cross-section that has my log specified and shows my Red River top pick. I'll go ahead and zoom out. So this is the well to the west that has what's probably the better pick. And here is my pick on that well that's a little shallow. I'm going to go ahead and move it down to the kick in the log. And when I edit this, my new change is automatically saved to the WellBase database. And I had previously set up my sources under the Tools menu to save any edited picks back to the source with the highest preference, which is myself. So I had previously had an IHS pick, a vendor pick. Now that I visited it, I want it flagged with my name so I know that I've actually looked at that well. We'll go ahead and click OK. Again, my change was automatically saved to the WellBase database. So now we can go back to Geo Atlas. Go ahead and close that. I don't need to save my section. Okay, so to update my contours, this is the layer that goes directly to the database. I'll right-click that layer name and pick Update Layer. This brings up the main ISOMAP dialog, and I'll go back to Data Sources. And I'll click this Refresh button. Now, I didn't add or subtract any picks, but I did edit one, and you can see that my average Z-value changed slightly, but my total points didn't change. So I'll go ahead and click OK here. And now I'll regrid based on that new edit. So I'll go ahead and click Finish. And that bullseye is gone, and this pick is more in line with the others. So I'll go ahead and zoom out, and you can see that that bullseye is gone. Now, if I zoom back in, you'll notice that that purple value is still showing the old pick, the IHS pick. So to correct that posting as well as my other ISOMAP layer, I'll show you the next workflow. I'm going to head back to my original contours, the ones that came from the purple posting. First step, WellBase layer, and update that layer. Now I've already specified that my pick is the highest over IHS, so we should get a trade right now once I click OK and update the layer. And now my pick is much closer in line with the surrounding picks. So to have my contours reflect that edit, I'll right-click on that contour layer. This is the one from the WellBase layer. I'll update the layer. I'll go back to Data Sources, and I'll refresh again. Now notice that this layer has a layer source, and it's going back to my Red River subsea, but it's not actually hitting on the database itself. It's hitting on a WellBase layer. So I'll refresh this. It queries the layer. Now I'll click OK and regrid. And now I've corrected that second bullseye, the duplicate bullseye. Okay, so we can zoom back out and take a look at this layer. So to kind of summarize the two workflows, there are two main workflows for contouring WellBase or cross-section picks. As you know, Prism and cross-section picks and geographics are saved directly to the WellBase database. The first option that I showed you in terms of updating was the layer that was directly from the database. So this was the second layer I created from the contour menu. The update path is to update the ISOMAP layer using the refresh button. Pretty simple and straightforward. Now with the layer that I had created from the right click from the WellBase layer posting, the update path is slightly modified. First I need to update my WellBase layer on change data Then I can update the ISOMAP layer using that refresh button. Okay, I've created my Red River structure. I've QA'd the obvious data area. Now let's look at some basics at setting grid parameters and best practices for contouring. Okay, I'm going to zoom in up on this northern section of my map. And I've already highlighted a few spots in yellow where contours are close to honoring the wells, but not quite. I've got a -10, 175 contour here, and it's lacing on either side of my two control points, whereas I really want it going straight through. I've got a -10, 176 that's just on the wrong side of the contour. Similarly, I have a -10, 300 contour that's coming close to this control point, but this little dip is not quite making it there. So I'll adjust this layer's grid parameters to see if we can get these contours to honor every individual pick. So first, let's turn on the ISOMAP grid. I mentioned that graph paper. I'll go ahead and turn the eye on, and you can see I just got a gray grid. Now, if I turn off my land grid for a second, this is the grid that the contours are actually lacing through, and it's laid down across the whole AOI. Now, to give you an idea of spacing, I'll turn my land grid back on. Each one of these red sections, so this yellow box, for example, which is one section colored in, it's 1 square mile, or about 2.6 kilometers square. Just to give you an idea of scale, this will be important when we start to refine those grid parameters. So let's turn that grid back off, and we'll update this layer. Now this time, I'm happy with my data sources, but I want to go in to my build parameters. First, we'll take a look at the gridding method. Geographics offers a variety. The default is minimum curvature. Now, this is a global method in that the software analyzes the entire data set at a very high level, and then it refines down to the individual points. Now, it produces geologically reasonable contours for most data sets. Other methods are available as well. You can see we've got adaptive fitting, which is another global method for small clustered data sets, and then there are a variety of localized methods available here. Now in this case, we'll stick with minimum curvature because it produces geologically contours, and this is a good one for this particular data set. The convergence and tolerance, the max iterations, and the convergence tells the software how long to process and keep refining its solution. In this case, we'll go with the defaults, but if I want it to process longer, I'll up the max iterations. If I want it to find a better solution, I'll reduce the convergence. So this is the percent change between each iteration. Now the rest of these search methods will enable depending on the relevance to the grid method selected. Next, I'll go to the grid spacing tab. Some of the most important grid parameters are located on this tab. So I've got a smallest feature radius. I'm going to round this value up to the default, which is 715. This radius defines the opening size of each cell in that ISOMAP grid mesh. So the gray lines that I showed were spaced at 715 meters. So this parameter is in map units. In this case, I'm using UTM, so it's meters. And remember that land grid spacing, that yellow section that's displayed, is about 2.6 kilometers squared. Okay, so when I set that smallest feature radius, the software creates this grid across the active AOI. So the combination of this smallest feature and the extent to my AOI define the number of columns and rows in the resulting grid. So with the smallest feature of 715, my grid has approximately 70 by 7 rows. Now this is a very small grid for the computer to compute, easy and quick for it to do. The computer can handle a lot more. So ideally, to make a detailed structure, I'm going to set my smallest feature radius even closer than my well spacing. So right now I have approximately 1 well per grid cell, but I want to get multiple grid cells between my wells. In this area, I can go to about 100 meter spacing. And when I click in another cell, the computers calculated that I have approximately 500 by 500 columns and rows in my grid. This is well under 1,000 by 1,000, and the computer can handle upwards of 3,000 by 3,000. But you can see that in order to use a dense grid, we want to be sure to work in an area of interest that matches the local area that I want to contour. It's best to set the smallest feature radius first and then see the calculated grid spacings in columns and rows versus trying to get the grid configured from the middle of this dialog and working outward. The smallest feature radius is what the software uses behind the scenes, and this is the impact on the output grid itself. Okay, I'll go ahead and lock that smallest feature radius in by locking my grid parameters, and I'll click OK, and then I'll regrid my map, which is set right here, and I'll click Finish. Takes a little longer with this denser grid, but now I can see that my -10, 175 contour is going right through those wells. My -10, 300 well has its own contour honoring it, and so on. The rest of these are on the right side of the contours. Okay. Now, just as an example for how important it is to work in an AOI, I'm going to repeat the same workflow using my global AOI. Now remember, the Williston Basin is quite large, so I'll activate my AOI using this AOI menu. I'll go to the project extents, and I'll go ahead and click OK. So I'll pick one of these WellBase postings. Now note, if I pick multiple things selected, I won't get that right-click contour option. So instead, I'm just going to pick a single posting, and then I'll get my right-click contour option. Quick contouring here, and wow, I have some really different-looking contours. I'll turn off my local map, and this really just looks like a trend to me. If I zoom out, I'll see it. I have such as something more refined. Well, let's zoom out to my project extents and take a look. So I'll set my map to my entire project now. And it looks like I have just mapped the entire northern Rocky Mountain region. My contours are here. My land grid is just a small red box right beside the Montana border. So I'm trying to map a very small area, but I'm really mapping the entire region. So of course I'm getting a trend that's not honoring my local wells. So let's zoom back in, but we'll keep this layer active, and I'll just see what happens if I try to refine it down to that 100-meter spacing. I'll go into Build Parameters, into that Grid Spacing tab. Now my radius is 22,000. Let's go to 100. Now I'm upwards of 20,000 by 12,000 grid cells. If I try to grid and contour this, I'll get a memory error. The software just doesn't want to deal with that many columns and rows. So to summarize, to map at this regional scale, we'd need to use that much less dense grid mesh. So whenever possible, you want to work in an area of interest that encompasses the area that you wish to map. Use a small AOI for local contours. If you need to map a region, use a larger but still regional AOI. Okay, let's turn that layer off, and let's go back to one of our better maps. I'd like to just briefly discuss a few other grid parameters. In particular, the radius of influence. Now, the tooltip says area of autocorrelation. Data points within the ROI are considered to be correlatable. That sounds very computer science-y to me. The way I think about it in geological terms, a large radius of influence, like the software defaults to, it tells the software that z-values don't change quickly from well to well. So think about a large regional structure where your subseas change in a fairly predictable, gradual manner. A small radius of influence, or ROI, tells the software that z-values do change quickly. So think about mapping karst, a channel sand thickness, maybe porosities, or even EURs, where you can't assume that the same thing's happening in between two wells. Now, I'm mapping a regional structure here, but to show the impact of this parameter, I'll go ahead and set it for a discontinuous structure. I'll reduce it down to 1,000 meters, and then I'll regrid. And I'll get a much more bullseye appearance, much more localized features standing out on my map. Especially down west. Okay, the one last thing to discuss in terms of grid parameters is some advanced parameters. Now the details are beyond the scope of this webinar, but this geologic tab includes the ability to apply a surface substitution, so to have another structure or layer impact your structure where you don't have data. You can set a bias trend to preferentially orient your contours, and you can also use this z-value projection to influence the placement of a zero contour on an isopack. These parameters on the screen, and it will take you right to the isomap help to get more details. And that's also true for details on any of these gridding algorithms. That's a lot to cover, but just to summarize, some of the best practices when you're contouring: reduce the smallest feature radius. The results of your contours will better honor your data points. Now that smallest feature, to remind you, is the grid mesh opening size in map units. And when you adjust it, monitor the number of columns and rows in the resulting grid. Also, be sure to work in an AOI. Use the smallest area of interest that best fits your data. Avoid contouring in global. Use a regional AOI instead, but if you absolutely need to contour in global, be sure to check your project extents first and make sure that your project hasn't grown to incorporate all of North America or all of Europe and Asia. You can do this in Project Explorer by right-clicking on your project name. You'll go to Properties and then check the Extents tab. Now in this case, I'm going from a latitude of 49 to 39, so about 10 degrees, and just ever so slightly wider east to west. So I'm still just in the Rocky Mountains, but still a smaller AOI is always better. Okay. So, and we'll just other data sources that ISOMAP can contour beyond formation pics stored in geographics. Now in my project area, let's turn off that ugly layer and turn back on this one. I do have a newer major producing zone in the Williston, and that's the Bakken. It has a lot of data down here where these horizontals have been created. Now, I've already created a zone in our Zone Manager application. I'll launch that right here. That describes the Bakken Zone. It's defined as the top of the Bakken, based on my Bakken pics, down to the base of the Bakken. In this case, I use several different pics as options for what's defined as the base of the Bakken. And what I want to do is map the thickness of my Bakken. So here's my zone, the Bakken gross, and I'll go ahead and view this data in a spreadsheet. I'll click OK on my Zone Manager application, and I'll open that attribute spreadsheet. So all the wells have XYs in the database, but the ones that have a base and top for the Bakken also have a measure depth. And now I'll create a thickness for this Bakken going from top to the base. We'll go ahead and use the Tools menu, and I've got a function to compute TVT TST data. Now I've got some horizontals, so I'll use the option to create a vertical thickness, top TVD to base TVD, and this is the top of my zone to the base of my zone. I'll go ahead and click OK, and the software goes ahead and calculates the vertical thickness for me of my zone. Now to map this, I can go to the Layer menu and create isomap layer. I'll go ahead and pick my zone name, which is the Bakken gross. The attribute that I wish to map is the vertical thickness, and I'll go ahead and give it a layer name. Bakken Zone Manager. I'll click OK, and it takes me right into isomap. So I'll go ahead and see my data source straight from Zone Manager. I've got a pretty big range of thicknesses here. I'll go ahead and click OK, refine that grid parameter. This time, oh, I'm still in global, so this layer will be way too regional and generalized, but we'll go ahead and grid it anyway. I'll make my smallest feature radius 5,000. It'll still be quick enough, and I'll get somewhat decent detail. So I'll click Finish. Now I'll go back to Geo Atlas and I'll add that layer to my map. And here's my Bakken, and I can see my thickness. Again, pretty generalized. I still map that in global. So as my best practices dictate, before I go on and create additional layers, I need to activate that AOI. So AOI, activate. And I'll go ahead and activate that SUPass field. So my next layers will be created in SUPass field and limited in their scope. Okay, in addition to using Zone Manager, other common sources for data within Discovery, within the modules, I can feed data in from Size Vision or Smart Section. But in this case, I want to go to an external data source. I've got a top pick that's not really in my database, and that's the Mission Canyon. I don't so much have it picked on my sections, but I do have an XYZ data file from an external source. So I'll import that, and I'll go to File, Import, Surface, ASCII XYZ Data Import. I'll browse to my data file, which is got a CSV extension. So I'll go ahead into this isomap folder, and here I have my Mission Canyon UTM tops. I'll go ahead and click Open and give it a name. I'll click Next, and I'm prompted for more information about my XYZ file. Now I can click this Quick Preview button, and it opens up my file for me in Notepad, so I can quickly verify or at least check some of these parameters. Now it looks like I've got my easting in the first column. I see that I've got a comma delimiter, a northing in my second column, and then I've got my depth and subsea in the third column. So it looks like my delimiter of a comma is correct. My X column 1 is correct, 2 and 3. If things were reversed, I could switch that right here. Now we don't see any nulls in this data, so I'll just accept the default null data. But if I had a null to specify, I'd do it here. I do have a header row to set, and then I'll click Next. And in this final screen, I'm asked to verify my data import coordinates. Now, those weren't lat longs in the files. Those were XYs, and those happen to be UTMs in Universal Transverse Mercator and Zone 13. So go ahead and select that and click Finish. Some of my data points might be slightly outside of my AOI. That's okay. I'm really just interested in this SUPass field, and it pops me back in isomap. Now I can see my layers AOI name, SUPass field. I'll go to Build Parameters. Note my default grid spacing is already smaller, and I'll go ahead and refine that down to the 100. And I'll contour my layer. If I turn off a few of these layers, I can see these tiny little red specks. And those are my control points from the XYZ file. There's one other very powerful format that it's very common, and that's the ZMAP plus ASCII format. A lot of common petroleum software packages will export this format. This format has an advantage over XYZ files. It specifies the type of photography data that's included in the file. So we'll go ahead and import this Mission Canyon data again using that format. We'll go to File, Import, Surface, and this time ZMAP plus import. So I'll give my layer name. This is Mission Canyon from ZMAP plus. I'll browse to my files. And in this situation, I'll have several files. I've got a grid file as indicated by this suffix, a fault, data, and the contour. So I'm getting the whole suite of data from another package. We'll go ahead and click Open here. Could be from another geographics user as well. Each of my data files is automatically placed in the right bin. The software reads the header from the file and places. It knows that my data file is an XYZ data file, the grid, and so on. We'll go ahead and click Next. Dealing with you, change my import coordinates to specify that I'm not bringing in logs. And I'll click Finish. Again, some of my data points slightly outside my AOI. In this case, not a big deal. It looks like all 4 of my files imported with no problem. So I'll go ahead and click OK. Just accepted the grid from the other application without trying to re-grid every data point. So I'll turn that grid off. And now I can see I've got my contours from the other package. They were clipped, as well as the control points. So if I wanted to regrid this, if I wanted to regrid and recontour, I could redo it using the control points. But in this case, I'm accepting that other grid directly. So to summarize, there are several common ISOMAP data sources. We went straight to the WellBase database. In this case, we contoured PICs. I could have also contoured production or EURs. I went to Zone Manager. Zone Manager has the ability to create all sorts of numeric data. It can store a huge variety of types, porosities, net thicknesses. They'd all be available for contouring. The other 2 modules that commonly feed ISOMAP data are Size Vision and Xsection. And then we also imported an XYZ file as well as a ZMAP plus ASCII format. So in conclusion, the integration between geographic modules allows Geo Atlas and ISOMAP to access many different data sources from within a project. A variety of symbology options exist to allow you to easily manipulate and display data to aid interpretation of your project area. Once you get to the point of contouring, you can use it for QAing your PICs. When you're contouring, be sure to work within a suitable AOI and optimize the ISOMAP grid parameters to produce geologically realistic contours that honor your control data points. Remember, ISOMAP has the flexibility to contour a large variety of data sources from within the geographic project. This includes WellBase data, Zone Manager, and ZMAP Plus files quickly to contour external data.